Okay, now we were going to look at solving inequalities using addition and subtraction. So these are basically one-step inequalities, solved very similar to what we solve one-step equations. So remember, equivalent inequalities have the same solution. So we're just going to try and keep making simpler equivalent inequalities until we end up with one that's basically the answer. So what are the solutions of n minus 5 less than negative 3? And then we're going to graph that. Well, if we have n minus 5 equal to negative 3, the way we would solve that would be, because this is subtraction, we would want to add 5 on both sides, and we would get positive 2. Well, we're going to do the same thing here. We're going to add 5 to both sides of the inequality, so n is less than 2. Our graph, of course, then is going to be at 2. We want less than, any point less than 2. Because it's not equal to, we're going to have that open bubble there. Next, what are the solutions of m minus 11 equals negative 12? Well, same thing. This is a subtraction problem. In order for us to solve it, we need to add. So we're going to add 11 on both sides of the inequality, same as we add 11 on both sides of the equal sign. So m is greater than or equal to, this would end up being negative 1. Negative 12 plus 11 is negative 1. Graphing this, we want to go to negative 1, and we want greater than negative 1. So all the points greater than negative 1. But because this says greater than or equal to, our circle needs to be colored in because we want to include the point negative 1 in our picture. All right, so this little blurb just basically says that whatever you do on one side of the equal sign, you have to do on the other side of the equal sign. If you add on one side, you have to add on both sides. If you subtract on one side, you have to subtract on both sides. So we're going to keep looking at these. Y plus 5 greater than or less than or equal to negative 1. Some people don't like the order that this is written in. I'm going to leave it like this. If you want to rewrite it, y plus 5 pointing to the y plus 5 is less than or equal to negative 1. I'm going to leave it like this, I guess. So to get y by itself, I'm going to have to subtract a 5, which gives me a minus 6. So y is less than or equal to a minus 6 if you switch it around. Of course, if you switched it around to begin with, you wouldn't have to switch it around at the end. And technically, you don't have to switch it around. This is fine. I just like it better like this. It makes it seem like it makes more sense in my head. All right, so negative 6 is here. We want less than negative 6, and of course less than or equal to, so we're going to shade our bubble in. All right, a word problem. A club has a goal to sell 25 plants for a fundraiser. Club members sell 8 plants on Wednesday, 9 plants on Thursday. What are the possible numbers of plants they can sell on Friday to meet their goal? So 8 plants on Wednesday plus 9 plants on Thursday plus how much? We want to sell at least 25, which means greater than or equal to 25. Well, this is 17. What could this number be so that we sell at least 25? I guess mathematically, if you want to put an X or something in there, we're going to be subtracting 17 from the 25. We need to sell on Friday more than or greater than or equal to 8 plants. We wouldn't just say we want to sell 8 plants because we could sell more than that and still make our goal. Okay, just because we have a goal, we don't want to stop at that goal. If we have time to sell more, we'll sell more. All right, so Friday we have to sell greater than or equal to 8 plants, more than or equal to 8 plants. And finally, what inequality symbol would you use to represent the following? Well, at least is going to represent, we want that number or more, so greater than or equal to. No less than is also greater than or equal to. At most and no more than are both less than or equal to. So if you're unsure about those, you might want to jot those down so you have them in your notes. You can refer to them. Most of the time, if you just think about it, you'll get it.